The future of nutrition is poised to move beyond simply counting grams of protein and toward a more refined, personalized approach that considers the precise composition of amino acids in the diet. Personalized protein diets aim to balance critical amino acids, particularly isoleucine, methionine, and leucine, to provide the body with what it needs for tissue repair, immune function, and metabolic activity without overstimulating growth pathways like mTOR, which have been linked to accelerated aging when chronically activated. This shift represents a fundamental evolution in dietary science. Instead of treating protein as a monolithic nutrient, we begin to understand it as a complex tool that can be tuned to optimize metabolism, health span, and longevity. By tailoring amino acid intake, future diets could maximize cellular repair while minimizing the metabolic stress associated with overconsumption of high BCAA or high methionine foods. For instance, moderate isoleucine and methionine levels, combined with sufficient leucine, could maintain muscle mass and strength while supporting insulin sensitivity and reducing chronic inflammation. This approach allows the body to maintain lean tissue and functional metabolism without triggering the subtle biochemical stresses that accumulate over decades and contribute to age-related disease. Personalized protein diets would not just prevent nutrient excess, they would actively create an environment conducive to cellular resilience, mitochondrial efficiency, and balanced hormonal signaling, all of which are essential for healthy aging. The potential of these diets extends beyond metabolism into the broader landscape of health and vitality. By optimizing amino acid ratios, individuals could experience enhanced energy levels, more stable blood sugar regulation, and improved cardiovascular and cognitive health. Personalized protein planning could also allow for adjustments based on age, activity level, genetic predispositions, and health goals. For example, older adults who require additional support for muscle retention could receive slightly higher leucine, while still moderating isoleucine and methionine to avoid metabolic overload. Athletes might rotate protein sources to stimulate growth temporarily while maintaining long-term metabolic balance. The flexibility of this approach makes it highly adaptable to individual lifestyles and biological needs, turning protein intake into a precise tool for longevity rather than a blunt measure of quantity. In practice, such diets would leverage both traditional and emerging protein sources, combining plant-based proteins, seafood, dairy alternatives, legumes, and even algae or insect proteins to achieve optimal amino acid profiles. This diversity not only supports a broader spectrum of nutrients, antioxidants, and fiber, but also aligns with environmental sustainability by reducing reliance on resource-intensive animal proteins. By carefully selecting sources that complement each other in amino acid composition, it becomes possible to nourish the body comprehensively while minimizing potential metabolic stress. This strategy mirrors the patterns observed in populations with long lifespans, such as the blue zones, where dietary protein is moderate, plant-forward, and varied, supporting both vitality and longevity. Moreover, personalized protein diets could integrate seamlessly with other aspects of health optimization, such as circadian nutrition, intermittent fasting, or exercise timing, to further enhance metabolic efficiency and cellular repair. By coordinating protein intake with the body's natural rhythms and activity patterns, amino acids can be directed toward muscle repair, mitochondrial maintenance, and antioxidant defense at the times they are most needed. This targeted approach transforms protein from a simple macronutrient into a dynamic instrument that actively orchestrates metabolic health, recovery, and longevity. Ultimately, the concept of adjusting amino acid ratios for longevity represents a paradigm shift in how we think about nutrition. It moves away from generalized recommendations and toward individualized strategies that recognize the intricate interplay between protein quality, metabolic pathways, and long-term health outcomes. By focusing on balance rather than quantity, personalized protein diets could maximize lifespan, preserve muscle and organ function, and reduce the risk of metabolic and age-related diseases, all while promoting sustainable and enjoyable eating patterns. In essence, this approach empowers individuals to nourish not just their immediate energy and strength needs, but their long-term resilience and vitality, making protein a tool not just for growth, but for graceful, sustained aging and optimal metabolic efficiency.